Dear students, welcome to Study and Learn Academy. I am Dr. Ganapat Nagda. Today we will continue the second lecture of Chapter 4, Class 9, Structure of Atom. So, how to calculate the atomic number? So you can see number of proton in sodium atom is 11. Find the atomic number and number of electrons in a sodium atom. Solution: since atomic number equal to number of protons equal to number of electrons, therefore atomic number of sodium equal to 11. Number of electron in sodium is also 11. Now you can see the various atoms structure like lithium, carbon. If you see in the lithium, the atomic number of lithium is 3 and average atomic mass of the lithium, that will be 6.941 AMU. Atomic number of carbon is 6 and average atomic mass of carbon is 12.01 AMU. So 3 protons plus 4 neutrons in lithium, the total is atomic mass is 7 AMU. And in carbon you can see 6 protons and 6 neutrons, 6 AMU plus 6 AMU, that is 12 AMU. Now the next concept is mass number or atomic mass. Mass number of an atom is defined as the sum of the number of protons and number of neutrons. Mass number is nearly equal to the atomic mass of an atom. Since protons and neutrons reside in the nucleus, thus they are also known as nucleons. This means mass number of an atom equal to number of protons plus number of neutrons. Example: atomic mass of aluminium is 27U and atomic number is 13. So find the number of protons and number of neutrons in aluminium. Solution is atomic number equal to 13. Therefore, number of proton equal to 13. We know that atomic mass, or you can say mass number, equal to number of protons plus number of neutrons. Therefore, 27U equal to 13 plus small n, or you can say small n equal to 27 minus 13, that will be 14. Therefore, number of proton equal to 13 and number of neutron equal to 40. The atomic number of carbon is 6 and number of neutrons is equal to 6. Find the atomic mass or mass number of carbon. So, atomic number of carbon is 6. Therefore, number of proton equal to 6. Now, atomic mass equal to number of proton plus number of neutron. So, you can say 6 plus 6, that will be 12U. Now, the next topic of this chapter is arrangement of electrons in an atom. How the electrons are arranged in an atom around a nucleus, that is called electronic configuration. The maximum number of electrons can be obtained by twice n square, where small n is the orbit number. Thus, after knowing the maximum number of electrons for a particular shell, the arrangement of electrons in an atom can be identified. It is called Bohrs-Bury schemes. Now the rules to write the electronic configuration of an atom. Maximum number of electrons in an orbit is calculated by twice n square, and n is the number of orbit and may be equal to 1, 2, 3, so on. Electrons occupy the next orbit only after filling the inner orbit completely. The maximum number of electrons in outermost orbit will not be more than 8. So you can see electronic configuration of hydrogen. So atomic number of hydrogen equal to 1. Therefore, number of electrons equal to 1. Maximum number of electrons in first orbit, that will be 2. Since hydrogen has only one electron, therefore it will reside in first orbit. Thus electronic configuration of hydrogen, so you can see this is the structure of hydrogen atom, and in center there is a nucleus, and number of orbit present in hydrogen, that is equal to 1, and only one electron is present in hydrogen atom, so that is found in first orbit. So you can see this is the picture of hydrogen atom. Electronic configuration of helium. So you can see in this particular slide the structure of helium atom. So atomic number of helium equal to 2. Therefore number of electrons equal to 2. So the electronic configuration of helium is, and number of orbit in helium atom equal to 1. So you can see maximum 2 electrons can present in first orbit. So in helium there is only one orbit is there, and both the electrons are accommodated in that orbit. In center there is a nucleus of helium. Now you can see electronic configuration of lithium. Atomic number of lithium equal to 3. So number of electrons equal to 3. Since the maximum number of electrons in first orbit is equal to 2, therefore after accommodating 2 electrons in first orbit, the third electron will go in second orbit. Thus electronic configuration of lithium is number of orbit in lithium atom equal to 3. 2. That's not a 3, 2. So you can see the picture, the structure of lithium atom. In center there is a nucleus, then around nucleus there is a first orbit, and outer side of first orbit there is a second orbit. So 2 electrons are present in first orbit and 1 electron is present in second orbit. So this is the electronic configuration of lithium. So you can see in next slide the electronic configuration of beryllium. Atomic number of beryllium equal to 4. Therefore the number of electrons equal to 4. Thus electronic configuration of beryllium is, and number of the orbit in beryllium is 2. So you can see in the picture there are 2 orbits around a nucleus of beryllium, and there are total 4 electrons present in beryllium because their atomic number is 4. So 2 electrons accommodate in first orbit and 2 electrons accommodate in second orbit. Now you can see the next electronic configuration of boron. Atomic number of boron is 5. Therefore number of electrons equal to 5. Number of orbit of boron equal to 2. So you can see how these 5 electrons accommodate in 2 orbit of boron. 2 electrons maximum accommodate in first orbit, and rest 3 electrons present in second orbit. Now the electronic configuration of carbon. Atomic number of carbon is 6. Therefore number of electrons equal to 6. and number of orbit in carbon atom, that is 2. So there are 6 electrons, those accommodate into 2 orbits, and maximum 2 electrons can accommodate in first orbit. So first orbit containing 2 electrons and rest of the 4 electrons present in second orbit. So that is the structure of carbon. Now you can see the electronic configuration of nitrogen. Atomic number of nitrogen is 7. Electrons present in nitrogen is 7. And the number of orbits present in nitrogen is 2. So first orbit having 2 electrons and rest 5 electrons present in second orbit around the nucleus. So this is the you can say electronic configuration of nitrogen. Then you can see electronic configuration of oxygen. 8 atomic number, their number of electrons are 8. 2 orbits are there in oxygen atom, so 2 plus 6. Then you, then you can see electronic configuration of fluorine. 9 is the atomic number. Number of electrons are also 9. So there are 2 orbits in fluorine atom. So 2 electrons are present in first orbit and rest 7 electrons present in second orbit. Then you can see electronic configuration of neon. Atomic number of neon is 10. So total number of electrons are also 10. And the orbits numbers are 2 in neon. So in first orbit there are 2 electrons and in second orbit there are 8 electrons. So that is the electronic configuration of neon. Then you can see sodium. Atomic number of sodium is 11. Electrons are also 11. So since in second orbit the maximum number of electrons is equal to 8 and there are 11 electrons in sodium atom, thus the 11th electron will go to the third orbit. So you can see there are 3 orbits in sodium and the electronic configuration is 281. 2 electrons present in first orbit, then 8 electron in second orbit and 1 electron in third orbit. So you can see in this particular slides all the atoms like hydrogen, lithium, helium, carbon, nitrogen, oxygen and their atomic structures and their electronic configuration, how electrons accommodate in various orbit of an atom. Valency. Now the next important concept, that is valency. Noble gases have fully filled outermost shell. Due to this, they are stable and they do not react with other elements. Other elements also tend to attain stable configuration by completing the octet in their outermost orbit. This is important to note that the number of electrons in the outermost orbit of an element is closer to octet. An element can lose or gain electron in order to complete the octet. This tendency of losing or gaining electrons imparts valency to an element. Let us take example of hydrogen. Hydrogen can readily lose or gain an electron. So its valency is 1. Now let us take example of hydrochloric acid, HCl. One atom of in this hydrogen loses 1 electron and thus gets plus 1 charge. On the other hand, chlorine gains an electron and thus gets minus 1 charge. So valency of hydrogen and chlorine are 1. Example, hydrogen molecule. If you see the hydrogen molecule, that is H2. Hydrogen has only one electron in its outermost orbit. Thus, it requires one more electrons to complete its outermost orbit. Therefore, in order to complete outermost orbit, hydrogen shares one electron with another hydrogen atom and form H2 molecule. So this is all about the today's lecture. Thank you very much. Goodbye.